All right, today we're going deep, deep underground to the border of France and Switzerland to check out CERN. This is the place humanity built to ask the biggest questions possible about our universe. So, let's jump right in.
And, the questions don't get much bigger than this one. We have a name for it, we call it dark matter, but what is it actually? The honest answer? We have absolutely no idea. And that massive mystery is one of the key drivers behind everything we're about to talk about.
And here's another one for you. And this gets right to the heart of why we even exist. Why do all the tiny little particles that make up you and me and this planet, why do they have weight? Why aren't they just massless bits of energy zipping around the universe at the speed of light?
Now, to even begin to answer questions like that, a telescope just won't do. You've got to go right to the source. You have to try and recreate the conditions of the Big Bang itself. And to do that, well, you need the largest, most powerful, most complex machine humanity has ever dreamed of building.
So yeah, let's start right there, with the big questions. This whole incredible endeavor, it's all built on pure, simple curiosity, on our ability to look at the cosmos and just admit, wow, there's some fundamental things about this place we just don't get. And as CERN's new Director General, Mark Thompson, says, these aren't just little gaps in our understanding. Nope, they are huge, gaping holes in what we know. And the only tool we have that's powerful enough to even peek into them is a machine that can smash particles together at almost the speed of light. This is basically the to-do list for all of modern physics. And you'll notice a lot of these questions circle around one particle in particular, the Higgs boson. That's the one they found right here at CERN that helps give other particles their mass. So is the Higgs the key to it all? Is it connected to dark matter somehow? I mean, seriously, answering any one of these could rewrite the textbooks.
Okay, so how do you get these answers? How does this actually work? Well, you create tiny little controlled Big Bangs, millions of them. And to do that, you need the Large Hadron Collider, the LHC. The journey of a single proton here is just wild. It starts out in a totally normal bottle of hydrogen gas. From there, it gets zapped, stripped down to a single proton, and sent on an insane ride. It's passed from one accelerator to the next like a baton in a high-speed relay race, getting faster and faster and faster until, bam, it's shot into the main 27-kilometer ring. Just to give you a sense of the power we're talking about, in that final ring, those protons are traveling at 99.999991% of the speed of light. They whip around that entire 27-kilometer tunnel more than 11,000 times every single second, and then they're smashed head-on into another beam of protons going the other way.
But here's the crazy part. This absolutely mind-boggling machine, it's not enough anymore. To dig deeper into those big mysteries we talked about, scientists need more collisions. They need more data, a lot more data.
And that's why this massive upgrade is happening. Starting in June 2024, the LHC is being switched off for 4 whole years. This is the biggest project they've taken on in 2 decades. They're literally ripping out a huge section of the machine and replacing it with brand new state-of-the-art magnet technology.
So here's the difference. The original LHC was all about discovery, about finding new things like the Higgs. This new high-lumi LHC is all about precision. They're going to make the proton beams 10 times brighter, which just means squeezing them into an even tinier space. That's going to generate 10 times more collisions, which means, you guessed it, 10 times more data. It's like going from taking one photo of an event to shooting it in super high-definition video.
And make no mistake, this isn't just a small upgrade. The tech they're putting in now literally did not exist when they first built the LHC. It's like if they upgraded the giant detectors by skipping from an iPhone 10 all the way to an iPhone 17. It's a massive leap forward.
And that incredible leap in technology isn't just happening at the big collider. See, over in another corner of the campus, scientists are tackling another one of those huge cosmic mysteries, but with one of the most exotic, volatile, and just plain weird substances you can possibly imagine, antimatter. So what is antimatter? It's basically the mirror image of everything we know. An anti-electron has a positive charge. An antiproton has a negative one. But here's the catch. The second it touches regular matter, they both just disappear. Poof, a flash of pure energy. Which, brings up a really interesting practical problem. If you can't put it in a container, because the container is made of matter, how on earth do you study it, let alone move it from one place to another?
The solution is just brilliant. Scientists use these incredibly complex and powerful magnetic fields to create a kind of bottle that has no walls. It just holds the antiparticles floating in a perfect vacuum. This tech is so good they can actually store antimatter for months at a time. And now they're even building a portable version of this trap, so they can literally carry antimatter across campus to do even more sensitive experiments.
Now, this high-luminosity upgrade is going to keep physicists busy for a long, long time. But science, well, it never really stands still. And the plans for what comes after that are just breathtakingly ambitious.
The scientific community in Europe has basically decided what the next great machine should be, the Future Circular Collider, or FCC. So, you know that 27-kilometer ring? Yeah, forget that. We're now talking about a tunnel that's nearly 100 kilometers around. It's a machine on a scale that is genuinely hard to wrap your head around.
And of course, a project that ambitious comes with an equally ambitious price tag. The estimate is around 15 billion Swiss francs. Now that is a huge number, no question about it. And it definitely makes you ask, is it worth it?
But you really have to put that number in context. First, that cost is spread out over 15 years, and it's shared by more than 25 different countries. But more importantly, these huge blue-sky science projects have a funny way of paying off in ways you'd never expect. Just remember, the World Wide Web, the internet as we know it, was invented right here at CERN, not to make money, but just so physicists could share data more easily. It's an amazing reminder that sometimes the most practical inventions come from just being curious.
So the feeling at CERN right now, it isn't that things are ending, it's that they're just getting started. There's a real belief in the air that with these new tools, they're right on the verge of finally breaking our current best theory of everything, the Standard Model. They think they're about to find a crack in its armor. And if they do that, well, that could open up a whole new world of physics, a whole new understanding of reality itself.
I mean, at the end of the day, this is the ultimate exploration, isn't it? We're asking the universe its deepest questions, and we're finally building tools powerful enough to maybe, just maybe, hear the answers. The only real question left is, what's it going to tell us?